Why would we do surfaces in a solid modeler? Well, when you're doing surfaces, what you're doing is you're really just working on the particular face or the surface of the part, not actually the entire solid. So you're dealing with a zero thickness, and it's just like the skin of the part that we're working with. There's a lot of reasons people do it. One thing is surfaces are very easy to keep separated from each other. When you're doing solids, it always wants to blend into one another. If you have one solid go through another, unless you tell it not to, it'll turn that into a single volume. Surfacing is different. It wants to keep itself as its own solitary item, and then you can use it for like keep out areas or a battery box or something like that, where you say, hey, in this area we're going to do this, and no matter what people are extruding around it, it's going to stay independent. Surfaces aren't always used for the entire model. You can just use them to cut something or use as a stopping face, as an up to when you're extruding. I'll show you some examples of that. The other two big reasons people use surfaces is for a 3D plan. There's a macro model when you're building a giant system like this little airplane that I have over here. If I have one single model that we're all using for the fuselage and the wings and things like that, it's a lot easier when they all snap together to have a seamless components. The same idea at just the single level. If we look at this part here, a joystick, which should be cut into a left and right sides. That's what's called a master model, where you actually build the entire model and then you slice it into several pieces. And when you make the updates to the single model, all the little pieces update as well. Another reason you might go into it, and this thing keeps popping up in front of me so I can't actually show you, but in red down there it says lousy imports. And I'll have an example of bringing in a file that's not coming in as a solid. Okay, let me go into SolidWorks, since that is my favorite place to be, and I'll just talk about creation of surfaces. So the surfaces get created a lot like solids, where they start off with a 2D sketch. If we look at the toolbars, we have extrude, revolve, sweep, loft, boundary. If I go into the surfaces, extrude, revolve, sweep, loft, boundary, it has the exact same names, and they get built the exact same way. The difference is that it's not going to be a thick volume of material. It's just going to be, like I said, a zero thickness face. So we can do sketches just like we do with a regular solid. I'm going to put a construction line in here because I'm going to be doing a revolve, but I'm going to use this tool called a spline. Now it's similar to a line. You'll see if I just put 2 points, 1 point, 2 points, it looks just like a line. The big difference is when I select on it, I get these controls where I can actually play around with the curve of it. So I get from point to point, but it's not going to be a straight line. It's going to be whatever curve I want to put in it. You'll see that when I select on it, I get these controls. These are set up by you whether you want to see them. When you right click on a spline, I've got it showing spline handles and control polygons. And I like those because it gives me the ability to make changes. The control polygon are these little triangles, and the drag handles are these. There's 3 different items on the drag handles that we can work with. The diamond shape just controls the angle that we're going to be going from. The arrow controls the magnitude of tangency, so how far off of this edge is it going to be going in this direction of this dashed line. And then the third one at the point actually controls both of them, the magnitude and the direction of tangency. If I right click on it again, there is another choice to insert a spline point. Now you want to be careful with this, and I'll show some examples of splines gone awry with too many spline points. But if you want to have more control, what a spline point is, in other systems they often call it a node, where I can pick this one particular point now and start making it even a curvier curve. There's a trick that I've only learned in one of these classes. I don't know where it's written down anywhere, but if you hold your Alt key and you're on a node, when you play around with the magnitude and the angle, it happens in both directions at the same time with the same amount. If I just pick on one side, I can control the tangents just in one direction. But you want to be careful with this because you'll see that when I'm moving this side of it, it also moves the other side of the node. So it does get tricky to control these, and there is, some rhyme and reason to it, and hopefully after this class you'll know a little bit more about controlling those. But that is a spline. And the reason I'm using the spline is because the quality of your surface has to do with the underlying sketch. If you have a nice smooth curve in your sketch, you're going to get a nice smooth surface. If you have a lot of jaggedy splines, or if you have straight lines and arcs and things like that, you're going to get a lot of tangency lines if you're using arcs and curves. And if you're using a spline that has too much going on, you start to get ripples in it. But with this, a nice smooth curve, it should give me a nice surface. I'll just revolve it like a solid. It has the same controls, the same end conditions, but you'll see that the difference is there's no thickness to it. And that becomes evident when I go to evaluate. See the mass properties? This has no mass. I can't apply a density because there's no volume. So you want to be aware of that. When you're creating surfaces, they're like ghosts. They're not going to obstruct your solids, and they're not going to weigh down the part or anything. They're just there for construction. Okay. There's a couple of ways I can build a straight curve if I have nothing, or a straight surface. If I have nothing to work with, I can just do a regular sketch like this. Go into my surface and extrude it whatever distance. You can put angles on this. A lot of times when you are creating surface geometry, it's because it's going to be an injection molded part with some nice organic surfaces. And a lot of times you have to worry about draft. So they do give you the ability to put draft on your surfaces. You want to be aware, if you are creating an injection molded part, which way the pull is and to draft accordingly. So that creates a second surface. And you'll see that in my feature manager tree, it's actually keeping them separate. Like I said, in a solid, everything always wants to merge into one body unless you tell it otherwise. With a surface, it actually wants to keep them separate typically. There's another way to create a linear edge if you have a surface existing. And that's with something called extend surface. So if I pick on that edge, I can just have it extend that surface. And there's two choices. I can have it extend that surface linearly or do the same surface. And if I've got a crazy curve or something like that, it'll extrapolate what it thinks the rest of the shape's supposed to be. This extrapolation is pretty easy because it's just going to do a revolve with it if I do the same surface. But watch this. If I do the same surface, it actually is the same surface. I just have one single surface body. And the reason why you're seeing an edge is because there's a sketch there, but you'll see there's no seam. It just shoots more of that surface off when you do the same surface. If you choose to do it linear, it'll shoot it off straight 90 degrees from wherever the edge you picked, like an extruded sketch, but you can see that there is a seam there. It still keeps it as one single body, but it can't really do the faces the same because there's a change in curvature there. All right, I showed you the regular spline. There's another spline that they added a few years ago that was enormously helpful in making nice surfaces, and this is called a style spline. Other softwares may call it a Bezier curve because of the guy who invented how to control splines this way. But you'll see that with this, I get these polygons instead of those nodes. When you're playing around with the nodes, it's really easy to twist the spline very easily. Where when you move that arrow a little, it'll flip the thing completely, maybe even make it do a loop. But with this, it's almost impossible for me to get a ripple going on in this spline. So it's a nice design tool for curves. I use it more often than not. The only time I use the other spline tool is if I have a 2-point spline or just a 3-point spline, something very simple. But if it gets into a complex shape that I need to control, I will do it with these. You can also add relations to these edges inside of the curve. I want that always to end up going straight up out of the curve. And you'll see we've got these controls. Just like with the other spline, I can right click on it and ask to insert another control vertex. When I do that, now I've got an additional area that I can use to pull and change that curve however I need it to fit. And it's a nice tool. You can get some pretty good right to shape splines if you're tracing over a picture or something like that. All right, I do want these to end up just about the same place, so I can put relations on them just like any other sketch geometry. All right, I'll do a swept surface this time. For the profile, I'll use that same profile we used for the Revolve. And for the path, I'll use this new style spline. So there we go. We can do sweeps, extrusions, revolves, lofts, all sorts of things like that. Do one more quick here. I'm going to do a loft next. I just want to build a simple shape like this. So if you're going to have a constant shape throughout your surface as it's traveling, just like with a solid, you'd use a sweep. But if it's transitioning between one shape to another, that's when you want to use a loft. Now, loft surfaces have been around for a while. They work just like solid lofts. I can use direction 1. I want to make sure that you get these guys correct. You'll see if it has twist and doesn't show you a preview, that's a bad thing. You can right click on a connector and choose to flip the connector, or you can drag the connector itself to the point. It's also a good idea when you're doing these types of things, whether it's a solid or a surface that you're doing, to have the same amount of segments. Like if you're doing a square, you'd have 4 segments. If you try and go to a triangle, you're going to lose a face as it's going into that other shape. So just to be aware of that, if you were going to do a triangle, you'd want to break one of those lines up so that you had 4 segments instead of 3. With a loft, I can only control the tangency of it coming off the other surfaces at the beginning of the loft. I'm going to do this curvature to face. So see how this, if I have it to none, it just makes a beeline for where it's going and transforms its shape into it. But you can see that I can have it come tangent off that end, and you'll see it pushes that surface out. Or curvature to face. I'm going to talk a lot about it. Curvature, it's an important detail inside of solids. What a curvature to a face means is that it's blending completely smooth into here. When you do a tangency, it's almost the same, but you can actually see a little edge where we're going from a straight line to a curve. When you do curvature to face, it starts blending in smoothly into it. If you have no end constraint at all, it'll just be angular. It'll just do a beeline to its next shape. Okay, so now I've got this shape. It doesn't necessarily have to be prismatic. If you see here, I've accidentally gone off the top here. So the bottom's not planar anymore. Again, this is all based on the surface geometry or the sketch geometry, just like when we're making solids. If I did want this to line up with the bottom of the part, I can do that, but I still am going to make the top a little taller. There we go. So the reason that I did it as a planar face is on the top face here. I'm going to start a sketch, and I'm just going to pick the bottom edges of all these surfaces and hit convert. That copies them over. Because I'm in later than 18, it gives me this nice shaded preview to let me know it's a closed surface. So if I wanted to, I could extrude this, but I'm not going to. It's a class about surfaces, so I'm going to use one. If you draw a sketch on a plane and it's a closed surface and you say planar surface, what it'll do is it'll fill that sketch geometry up with surface geometry. So again, take a look. It's keeping it as separate pieces. If I want them to be one, that's where this tool called Knit Surface comes in. And what the Knit Surface allows me to do is I can add surfaces together. Notice it's got to create solid. It's grayed out because I can't create a solid out of this. There is an open face on it. It does have a merge entities. People get confused on this. If I had made this in two planar pieces and there was just a seam between the two planar pieces, the merge entities would turn that into one planar surface. It usually only happens on planes when you're talking about merge entities. If you've got surface on top of a surface and they're on the same plane, it just merges them. Also, it's got a gap control. I built this part pretty solid, so I don't have to worry about gaps, but sometimes when you're doing imports or some stranger geometry, you may end up with a small gap in between your surfaces, and this will close those gaps for you. I say OK, and it's turned it into one surface here. Now you can just create a solid from this. I was talking about why do you want to use surfaces in solid geometry? Well, sometimes you have a particular surface that you're trying to capture, like the outside surface of this shape. I can do it with surfaces, and then once I've got my shape, I can choose to thicken that mid-plane, inside, outside, make myself a bowl, turn it into a solid that way. Or if you do have an enclosed volume, you can make it into a solid. Let me right-click here. Once I've got a knit group, I can do things like, say, give me the open loop, and it'll find where the hole is in that knit surface. And I can do something called a filled surface. What a fill surface does is it's similar to a planar surface where it's just going to fill that area in with surface, but the difference is it's not planar. By default, it will just come straight off of the edge of the part. So if I do that, you'll see that I can put a top on this, but it's not a planar top. I can tell the difference between a planar surface and a non-planar surface really easily. If you select a planar surface, you'll have a choice to open a sketch on that surface. There we go. So I can open a sketch on that face. This face, no choice to open a sketch because it's not an actual plane. It's a curve that's filling in that geometry. So that fill surface is really nice. I'm going to come back to it. It's kind of like sticking gum into the thing, filling the holes. Also, now you'll see when I knit and I choose these two pieces, there we go. I've got a knit solid. We can create that. Hold on one second. I think I just got too sharp of an edge here. Something. No, it's just trying to drive me crazy. Let me try this one more time. So I've got this knit surface. Nope. All right. Sorry about this. My example is not cooperating with me. So let me just try another quick one, make sure that the whole thing's working here. I showed you the extend surface, right? If you want to go straight out There's another type that you can do. It's called a ruled surface. It's similar, except at this one, you're putting it to an angle. Instead of going perpendicular to your plane or to your face, whatever you're doing, you can go normal to is the default, but you can also do tapered. If you want it at a particular angle, you can do that, or at a perpendicular to a particular vector. These are especially good when you're splitting castings and things like that. Anyhow, let me just make sure that I haven't lost my mind here, and then I probably just did some geometry wrong in this last one. Because the trick I wanted to show you is that if you have a knit surface that actually creates a closed volume, so I must have made a mistake in one of my sketches in that last one, you will get this choice to create a solid. And that only happens when SolidWorks runs a test and it finds no gaps in the part. If it finds out, hey, this is enclosed, that choice will become an option, and you can turn your enclosed surface volume into a solid body. Okay, sorry about that. Let me just find out where I am. Threw me for a loop. Okay, that was it for that example. Do you guys have any questions on just basic surface creation? How I was able to get these bodies and put them together? Okay, then let me open up another example here. I showed you a loft surface, which you've seen before, I'm sure, with a lofted solid. There's another one called a boundary that was another recent addition to SolidWorks, along with the Bezier curve, that really opened up possibilities for us. The difference, it's really a loft is what it is, but it's sort of a super loft. It can do a couple of things that a loft can't do. So if I said I wanted to loft that shape along that shape, it has no idea what I want. It doesn't give me a preview, it's going to fail. But if I do the same thing with a boundary surface, there we go. It does a lot of extrapolation. Also, remember when I was doing the loft, my tangency controls that I had were only at the beginning and the end. I had the two choices at the bottom, said start tangency, end tangency. Here, however many pieces I put in here, I can put tangency to any item that I pick. So you can do every cross section or every guide curve can have its own tangency control. So it gets really advanced into the shapes that you can get. A lot more control than you get with a loft. I talked about people importing things and having trouble with their imports. A very popular one is people will import something like an IGES or a step file as surfaces accidentally or maybe on purpose, and then later want to start making changes to that. They start a sketch, they go into their features, and they go to cut, and it's grayed out. It's grayed out the same reason that mass properties on my evaluate was grayed out, because there's nothing to cut into. There is no solid volume for me to remove. So how do we make changes or holes in a surface? Well, you need to use your surface toolbar, and we can do something called trim surface. Trim surface is pretty powerful because there's a lot of different ways to use it. I'll be showing you them as we go through here. But mainly what you do is you pick a trim tool. It can be a sketch, it can be a plane, it can be another surface. And then you can either pick and choose the pieces you want to keep or delete. It's up to you on whether you're going to remove these or keep them. And what it'll do is it'll put holes in my surface. Okay. Now that I've got holes in my surface, I want to talk about taking holes out of surfaces. I showed you the fill command that's pretty nice for like spackle. If you just want to fill a hole, you got an imported body or something, you can pick an edge or a series of edges. You see, I pick this series of edges. It shows me what I'm going to do. Right now it's just contact, so it's going to be not very close to the curve. I can get it closer and closer to the curve using these tools, tangency or curvature. You can see the zebra stripes that I have turned on here change a bit when I go from tangency to curvature. What it has to do is how smooth this is. They all looked pretty much the same to the naked eye, but the big difference is when I have this thing set just to contact, when I have a reflective scene, a lot of times you'll see a change in direction or a change in the reflection of it. Let's do it on this surface as well. And this one's much more pronounced. See how that reflection does not add up? How I'm doing that is I'm using my real view, and I've given the material something shiny. A lot of times I'll use brass or steel, chrome, something like that, so I get a nice reflection off of the surrounding environment. And that is for me to do like real-time zebra striping. There's actual zebra striping here. If I go to my evaluate, where you get your measure tool and stuff like that, you can go in here and see this thing called zebra stripes. It's from the automotive industry. They used to put the car that they were modeling, the little clay car, coat it with a shiny metal and then put it in a room full of lines and see if they had any of these non-tangent edges, because they were trying to get a nice smooth surface. Same thing with planes. So that's where we're getting the zebra stripe choice from. But I can really see that I've got some problems here. If I go into the surface again and change it from contact to curvature, I get a lot closer to the real thing. Okay, so you can use those. Notice that when you use the fill, it actually adds a surface. So if I wanted those to be part of my surface body, I would need to knit this together. There's another way to do this, though. There's a couple of ways to do it. And those are on my surface toolbar. So far I've used the fill surface. There's a delete hole and an untrim surface also will work for me. So untrim sounds weird because it's not really a word. What is to untrim? So I showed you trim, where you take a sketch and you start popping holes inside of your surface. What untrim does is it creates the surface that's missing. It's kind of a magic tool. I'll pick the 4 holes on here because it only gets the magic when I turn this merge with original on. They're gone. There's no sign, there's no edge, there's no other surface there. So it pretty much just disappears. And the untrim's pretty powerful. I showed that you can pick individual edges. You can also pick the whole thing. And it has options whether you want to fix the external or whether you want to fix the internal, or all of them. You can also pick an edge like this. You have a choice whether you just want to do a beeline between the two endpoints or whether you want to extend the edges until they would meet. But it does the same trick where it fixes it up, and there's I keep forgetting to check on that option. When I merge results, I just have that single body. So definitely untrim's the way to go if you're trying to get rid of a hole forever. Fill is really just, like I said, it's like spackle. You're just sticking gum in a hole. You want to fix it. Sometimes if the untrim doesn't work, fill's what you have to do, but untrim's a much better way of doing it. In fact, it's so good that this delete hole is pretty much the same thing. Where if I say delete hole, and then I pick edges of holes on the surface, holes disappear and I still just have one body. So it's pretty much just activating the untrim, but it's only for particular holes. And here's your quick trick for the day. If you pick a hole on a surface and you hit the delete key on your keyboard, gives you a choice. Did you want to delete the surface or just that hole? If you hold your control key and you pick a bunch of them, hit delete, it'll do all of them. That's why they've got the little S here for plural. But that just does the same thing. If you pick on an edge, hit delete hole, it does that delete hole feature for whatever edges you picked and basically does an untrim for your holes. And again, I talked about the fact that we can make surfaces come off at an angle or extrapolate them out further. So those are your main controls. Do you guys have any questions on any of those concepts? Okay. I had one more that I wanted to show you, just as a quick example. And that was when I talked a little earlier about files that come in incorrectly. So here's an IGES file. When you're dealing with imports, the best thing to get would be a parasolid. That's the closest to SolidWorks you can get. And then a step file would be next. That is a 3D model that has volume inside of it. It is a solid model. When we're dealing with one of these .igs or .iges files, an IGES file, they typically are called in the biz, those are surface geometry bodies. So it's just the outside of your part when you send somebody the IGES. It doesn't have the solid volume inside it. It's not a solid model. The trouble is that when people send you an IGES file, if it's able to knit those together, all of the surface bodies in that IGES file, it will give you a solid. If it can't do that, it won't. Whenever you open up an imported file like this, SolidWorks will ask you this same question. Do you want to run diagnostics on this? A lot of people say, don't show me again, no, which is perfectly all right. But what that means is every time you open it up, you're not going to know if there's an error in your imported part. I can tell there's an error because I thought I was getting a solid body and I have a surface body here. If you want to run diagnostics, you have to do it before you start doing any modeling. I can, start sketching and put chamfers and fillets and stuff in here, but once I do that, I can't run the diagnostics anymore. So it has to be done right when the part comes in. I can right-click and say, import diagnostics. This is what would have happened if I would have said yes to that question. So it says, okay, I found a bad face. Well, there's the bad face. It found a gap. Did it ever? Look at the ginormous gap I've got in this file. So I've got a choice down here that says attempt to heal, which it used to say try to heal. I guess attempt is a little more positive, but it's still hedging its bets. It's not going to say heal. It's going to say I'm going to try to heal. So I'll hit attempt to heal. If it works, you get a green check mark here and the things start disappearing out of the gaps. Sometimes you have a part with a lot of gaps. You may have to run the attempt heal more than once to get all of the gaps fixed. Sometimes it just doesn't fix. Sometimes you end up with some gaps. If you do just have a few gaps, you can use the fill command to fill in those gaps and try and create a solid out of it that way. But this one, it was able to do itself. And so it just did it manually for me. What it did was it put a fill surface in there, knit them together, formed a solid for me in one shot. But that's not at all what I really wanted. That is, it's a solid. That's a plus. I can use this delete face again. So if you just delete a face when you're in a solid, it turns your solid into a surface because you've torn a hole in it. It's no longer an enclosed volume. The other choices they have is a fill, which is what happened the first time. But then this last option right here, delete and patch, what that's going to do for me is it's basically like an untrim. It's going to continue this cylinder down to this flat face. It's going to continue this flat face down over to the cylinder. So when I say delete and patch, it just fixes it. I got a flat surface. I have a cylindrical boss coming off of it, and it's a solid body. So that delete face, it's pretty nice. Again, you can go from solids to surfaces. You can just tear a hole in your solid, make a surface. Sometimes I'll do that if I want to start manipulating the surfaces more. Or you can also use it in this case to fix up things, because it takes the surface out of there and fills the surface, knits it together, puts it into a solid all in one shot. So it's a pretty nice tool. That delete face. All right, I do talk fast here, I know, so if you guys have any questions, please let me know. Okay, so now I've shown you the basic moves that you can do with surfaces, creating them like solids, extrudes, lofts, things like that. Also manipulating them, taking edges and making them longer, shooting a parallel edge off of it or perpendicular edge off of it. Fixing holes, making holes, all sorts of things that you can do with surfaces. The thing is that you do want to make a lot of surfaces. One thing that people will do, a big mistake if they're trying to build something like this joystick, is they'll try to do it in one, the most of the body in one single loft or sweep or something like that. And it really ends up just looking like a blob of nothing. So let's take a look at some surface designs here. Notice one nice thing when you're dealing with a part that has a lot of features, it's a nice thing for other people who have to work on it to do this for them, to put it into folders. You can just grab items and make folders. It's just nice for the other people to have to work on it if they know they're working on the thumb rest. It's all these features in here. And you can roll back to, this is the area where all the thumb rest features do. So you should roll back to it if you want to make changes to it. It's a nice thing to sort of group where things are going to be. Surfaces are a little more difficult to keep in order or to keep some sort of sense of things, because they don't have as much parent-child relationships. Solids are always building off of each other and things like that, where surfaces a lot of times are independent. And so you can move them around in the tree without affecting other ones. So it's a good idea to sort of put an idea of where we're doing things. And this is a popular way to start off, is just using surfaces for construction geometry. So I made this first thing just to show where the base is. Also, another misconception that we get a lot is that you need to always use solids or always use surfaces. In this subcategory one, you'll see that I've got an extrusion right here. So pretty much right away, I started off with a solid body. You can mix and match solids and surfaces. It's not a problem. So don't think that, I'm going to build this thing out of surfaces. I have to do it completely surfaces. Or same way, I'm doing this thing in solids. I miss my chance to do surfaces. You can always mix and match them. Use whatever tools you need to get your job done. There's some interesting features in here. Here's one called Freeform. I haven't talked about that yet, but Freeform allows you to pick a face and on this face, I've got the ability to control this sort of like a NURB modeler, where I can actually click and drag on points and pull them here and there. They work a lot like a spline, same sort of controls. And I can add as many curves as I want and as many nodes with these points, and just click and drag on these. As long as I turn the edges to movable, I really have carte blanche on making this thing any shape I want. Now the next one I did was a replace face. And there's two ways this can go. So if we take a look at our feature, if this surface was all below the face, I would probably use a cut with surface for the tool, because I can just take that surface and cut one direction. The problem with this one is I had surface on top and bottom, so now I've got this like gap here. So a surface cut is good if it's only going in one direction, right? You're just saying, okay, from the top that way, cut. But the problem I've got here is this thing is actually going over the top of the face. So see, this isn't going to cut anything. I would have either needed to make the extrusion bigger, or there's another choice I can do. It's called replace face. And what this feature does is you pick the original face that you want, and then the face you wish it was, and it'll make that first face shaped like that second face, whether it has to add material or remove material, where cut just removes material. So a pretty powerful tool. You got the replace face and the cut with surface, both great for modeling and cutting away at your solids with your surfaces. Okay, but if you take a look at how this thing was done, again, I didn't try and do it all at once. I did piece by piece. Here's the flute shape that I want. Okay, let's trim out a little bit because I need to put in these little finger ridges here. If I had tried to put the finger ridges in when I was doing the loft, as the loft was going up, those finger ridges would have affected the backside of it too. It's when you're dealing with something like a loft or a sweep, and you're pulling, in different directions, trying to keep things tangent in different directions. A lot of times you'll end up affecting geometry you didn't want to. So that's why I did the surface just as a quick flute with a little bit of an indent for where the hand goes, but I didn't try to put in the finger ridges until I put them in independently so they wouldn't have any effect on this surface. Okay, but you see that it can get pretty complex. Tons of surfaces going here. This is a lot like what most surface bodies, or what a lot of surface models will look like, where it's tons of surfaces, and then at the end, they knit them together to make a solid. If I go to my Evaluate tab, look at the performance evaluation here. This thing takes 6.25 seconds to rebuild on this computer. That time will be different for different computers. It's based on my processor speed. But still, what that means is that anytime I make a change here and something has to rebuild, I may have to be waiting 6 seconds for it to happen, which doesn't seem like a lot, but if I make 20 changes and I keep having to wait that time for the thing to rebuild, it can start to drive people crazy with how come surfacing takes so long, this is so slow. Okay, it's still going to take a long time to rebuild, but a couple of years ago, SolidWorks gave us this little yellow bar here. You want to make sure that you have it activated on your system. In the general, there's this thing called Enable Freeze Bar. I believe it's on by default with our load, so you should have it on already. But what it allows me to do is I can take this bar and drag it down. So it's sort of like the rollback bar, but it's going the other direction. You see the little padlock that it's put on these features? That means those features are no longer going to rebuild. So now when I go to my performance evaluation, instead of 6 seconds for every change, now I'm down to 2 seconds for every change. So a lot of times I'll use that just for myself, for my own sanity as I'm building a part. It's like, okay, the thumb rest and the handle are done. I'm just working on these blends and patches. And as I'm doing it, I don't want to be sitting there and watching every time I hit rebuild this hourglass of waiting for the 57 surfaces ahead of it to rebuild. So if you keep this down at the bottom, the further down you go, now it's 0 seconds per rebuild. So I can start putting features on this and not have to worry about the rebuild. It also kind of protects you from errors happening in that, because once it's locked, it's not rebuilding at all. It's just got that shape. So it's a great tool for a time saver on rebuilds. It's also just a good one for a little bit of security. Anyone who wants to change it can always just roll it back to make changes. But if you try to make changes to something that's locked, there's no edit on there. You can only edit features that are unlocked. All right, one more nutty example here of one of those things that's got a lot of features to it. So go into our performance evaluation. Holy cow, this one's 20 seconds. This is more like it. These are what happens when you start to get a complex surface model. You get a lot of rebuild time. So again, it's a good idea. Do your friends a favor and yourself a favor by moving that freeze bar once you finish with a particular section, and also keeping the sections segregated in these folders helps out as well. So with this one, I started off with a head. They're easy enough to get. You just go to Grab CAD, get yourself a head. But I wanted to talk a little bit about the next idea in surfaces. One of the reasons that surfaces are so good is the fact that I have much more control over the blend from one section to another. And I talked a bit about it with the zebra stripes. There's also the curvature. So if you ever start to see colors ripple through here in your curvature, that means that you've got like a not very good surface. The way to read these surfaces is flat surfaces are black. Then as they start to curve, they go blue. When they get really curvy, they get green. And when they're a tight curve, it's actually a red shape. So if I go through here, I can start to take a look. Now the red here, not that big of a issue for me. I mean, I wanted a fillet there, so I'm not surprised that it's a tight corner. You'll see that when you hover your cursor over the graphics area, when you are in this tool, it will actually show up what the radius of curvature is. When you do have a blend like this, this is a nice curve. It's got what they call some curvature continuity. If it didn't have any continuity, this would just be bright red, the whole thing. But you can see that I've got some green and some blue inside of my fillet. That means that it's starting to blend from being a very flat curve to being a sharp curve, not instantly, but gradually. You can also see where you might have issues. I'm having a whole lot of problems in here. Again, once you start to see ripples like this, also, spikes in curves and things like that, that curvature command can help you target areas that you might need to work on. And again, a lot of surfacing is doing patchwork. At some point, I cut away that geometry and added a new one so that we wouldn't have that horrible curvature in there. Also, what the curvature does, as I showed you before, is you can make it so that the zebra stripes are continuous and don't have, if I saw this have a break or go at a different angle, I would know that I had a problem with the blend between those surfaces. So a lot of times when you are working with surfaces, those zebra stripes and curvatures will help you know what's going on. When it comes to curvature, a lot of times you'll hear curvature continuity. In fact, I've talked about it several times just in the property manager when I've been setting up things like lofts and boundary surfaces. It asks me whether I want things to be tangent or curvature, continuous, or contact, these first three. So contact, this one here, no curve. That's when you've got an angular corner, you got G0 or C0. are the two letters that people use depending on what software or math they're using. You'll either see a C or a G. But we're using G on this example. G0, you got an edge with an angle. G1 is typically what you're used to when you are putting in just a regular old fillet in SolidWorks. When you have two edges and you put in that fillet command just with a regular variable or constant radius fillet, you'll get this where you've got a straight edge and then all of a sudden it's going into a curve and then back to a straight edge. When you see that in SolidWorks, you'll see a seam there, and when you put in your zebra stripes, you'll see the edges of those change. What about these two over here? So this is where we're starting to get into the true curve, where there's not going to be, I don't have a seam in between these two. It gradually builds. This is the type of thing you're going to get when you set curvature continuity on a fillet command or on a loft or a boundary. This one, typically, you're only going to get inside of your sketch. That's why I want you to use splines, because especially the style spline is great at giving me G3 curves in a surface. And here's what these things look like when we're looking at it with zebra stripes. And it's very nuanced. Sometimes it's hard to see exactly what the difference is in this. So here we've got one that's just got a regular fillet up here. This one's got a fillet with curvature. This one I did a blend face. And this one I did a trick that I'm going to show you in the next example here. This one is as close to G3 as I could get. And that was using a sketch command. And the difference that you're seeing in them, if I looked at this one, I guess I did not take a picture of it, but it would just be solid red. Black flat, solid red, green, definite transition in between them. When I set up to tangency, it starts to move it a little bit more. When I set it to curvature, you'll see that it backs it off. And then this final one, we get it where it's a gradual blend throughout. And that's what we really want when we're dealing with these curves. So I would like to run through an example. I will be sending you guys these example files a little later. If you want to run through them after class, that's fine. I'm going to run through the first one here. And what these parts are is I'm going to build an upper and lower leg for this little robot. Whoops. Okay. Forgot I had this one in the vault, but here we go. This one was built with surfaces, and I'm not really happy with the surfaces. It was a good enough thing. It was really quick for lofts, and we were able to build a little prototype, make sure that the guy could dance and his speakers worked, but now we want to have a better shape on this. So I'm going to be doing new designs for the foot and thigh here. So I'll do the thigh first. I'll do the foot if I have time in the class, but there's a lot of stuff to cover in this. And I'll bring up this. So here we go. What the heck's going on? What I've done here is I've inserted drawings that I made. This is the leg that I would like to have on there. Here's how you can insert a drawing into SolidWorks. You start a sketch, and then you can either type in sketch picture up here, or I use it so much, I've got it customized to my toolbar. And what that allows you to do is I can browse for any of these, JPEGs, bitmaps, TIFFs. Try and stay away from TIFFs and bitmaps just because they're usually gigantic, and so you run the risk of having a 5 meg file before you've even made a single surface. PNGs are probably the best. But let's see what I've got. I think I got JPEGs. Hold on. Dang it. Sorry about this. Give me 1 second. I'm missing my original files. Okay, I am not finding them. So I will just show you how to insert a picture here. Heavens. Okay. Any picture will do. So once you've got whatever you want in there, you have some options. If you're going to use a scale tool, if I know like the distance between these two lines, and it's kind of tough, you have to zoom in while you're doing it here. I can put that in and say, I know that that is supposed to be 75. And it'll scale the entire picture to make that piece 75. When you do that, you're not able to change the size of it because the size of it is determined by the scale tool that you've used. If you don't use the scale tool, you can free drag it. It is set to lock the aspect ratio, so if you do go to make it wider, it'll automatically make it taller, unless you turn this off. But then you run the risk of squishing your original picture. You can also change how it's flipping about the X or Y. So that's how you can make a picture. Let me go into the picture here. You can edit it as well. Get out of sketch. Going to edit this sketch. Once you've got a picture in there, if you double click on it again, it'll take you to that same control. This is what the picture looked like when I originally did it. This is just something that I like to do. A lot of times I'll bring it in on graph paper. And then when I say, hey, anything that matches this color, depending on which color you grab, wherever your cursor is, that's going to be cleared out. So you can set up transparency so you can see through the sketch. I like doing it on graph paper just because I have these little ticks here where I can see what every 1/4 inch is. Helps me scale things. But you can just draw a picture or you can put in a picture from the internet. But that's what happened here. We ended up with a picture of what this thing looks like from the front and what this thing looks like from the side in 3D space. Let me go into this sketch. I'll hide these guys for a second. Because I wanted to talk about what this is. I was talking about how SolidWorks is the curvature using fillets and features such as loft and boundary. A lot of times it's hard to get exactly your G3 that you're after. I saw this on somebody's blog, a way to create it. And how he created these corners here was using a style spline. So the thing is that you want your corner to gradually go into the opposite direction, right? But you want it to be an equal type of transition. So if I pick these 3 lines, make them equal, these 3 lines, make them equal. So, oh, hey, there we go. I start to get what I'm after, but not really, because the other thing I need to do here is I need to make sure that these line up with each other. So now I've got a corner that gradually goes from one to the other with a perfect curve, where I can set this up to be collinear and collinear with the other edges that it's coming in contact with. In this one, I've actually got this thing with draft. Again, if you're building a part that is going to be injection molded, you want to make sure that it can come out of the cast, or out of the injection mold. And so that's why I've got that draft on there. The direction of pull is going to be this mid plane here. And so I've got draft on that, and I've got completely smooth corners. So I can create a quick revolved surface here. There we go. And now I want to make another plane here. So I'm creating a new plane, starting a sketch on it, drawing an ellipse. So if you've never used an ellipse, the construction is very similar to a circle, where you start off with the center. You pick the centroid of your ellipse, and then you drag out a minimum axis and a maximum axis. And that gets you the shape that you're after. And I just need to type in the numbers that I'm after here. You'll see it's not fully defined yet, even though I've got the centroid. The thing is that it's free to rotate. So in order to get this thing fully defined, I'm going to set up one of these axes to be lined up with the origin. There we go. That's the shape I want, which is the inner thigh here. I'm going to show this. I've got 2 sketches here. One is a circle, one is an ellipse. And so whenever you're dealing with this type of geometry that you're lofting from, you do want to be careful where you select. So when I am lofting like these 2 surfaces, it depends where I pick. See that little green dot? I can get this thing twisted up real easy. So in this one, at least I've got some geometry that I can use as sort of homing where exactly the heck I am. Like that mid plane or that axis. And so you want to get it straight up and down. I'll show you a little later. You can also go around in a circle. If I have any guide curves, it's better to use the guide curves along than it is to use the circular ends, just because the circular ends run the risk of that twist happening. So I've got it going straight from the front of the knee up to the front of the thigh, but I do want to give it more of an hourglass shape, and that's where I can use these controls. A lot of people get confused on what these controls mean. It's not a distance, it's a ratio. So if I go to 3, that means it's going to go all the way up to the next cross section, and then it's going to start blending out. So halfway up would be 1.5. If I go 4.5, that's going another half up and then coming back down. Maybe if I was making a horn, that would be the shape I was after, but not what I'm after. So it starts off with 1, which is a third. Again, don't think that that's an inch or a meter or a millimeter or anything. It's not a distance, it's a ratio. And you also have the control where you can put draft on it if you want. Again, when you are thinking about draft, an injected part, this shape of this feature is actually perpendicular to the draw, so I'm not really worried about draft in this particular direction. But there we go. I've got another shape. And I'm going to use my trim command. No. All right. I'm going to use my trim command. And last time I used the trim, I used standard. And I told you that when you're using standard, you can use a surface, a plane, or a sketch. And when you're using a sketch, it just shoots the sketch out perpendicular to the sketch plane as if it was getting extruded. You can use other surfaces. If you have it set to standard, you're just taking one surface as a cutting tool and cutting other surfaces with it. But there's another option called mutual. And what mutual allows me to do is it allows me to it's going to cut both surfaces at the same time. So I know that there's a full cylinder here. I don't need the top of that. I also know that this thing has this little neck down here. I don't need that. So I'm going to say I'd like to keep the selections here and here. And you'll see it's only showing me what's remaining. You have options as to what you want to see, whether it's just showing you what you're keeping or just showing you what's getting cut away, or both, and the cutaway stuff being shown in a sort of transparent color. So it trims it up for me. There we go. Finally got that thing to hide. Don't need to see that either. Just want to get this a little bit cleaner. Notice that it not only cut the surfaces using each other, instead of me having to use the knee to cut the thigh and then use the thigh to cut the knee, I did it in one step where they cut each other, and it also trimmed them together into a single body for me as well. So it's a pretty powerful tool using the mutual trim. So now that I've got the shape down, I want just to have a rounded top on this. I showed you the filled surface before, and by default, it's just going to cap it off for me. But I do have options onto whether I want to go tangent or curvature, and that again is talking about whether I want G1 or G2 when we're looking at the edge of this, how the two faces come together. I can also reverse it so that it goes upwards. And so now it's going to come perfectly smooth off of this curve, and that curve would actually terminate if it was extended, and so that's what it did for me. Well, I've got a nice smooth surface at the top of this, and if we go into our zebra stripes, it's just a nice smooth single surface here. Even though I've got this seam, we're not going to see it when the part gets made. Okay. Any questions for me so far? Hopefully this is helpful for you, seeing some of these ideas on how to create parts. I'm going to show these sketches again, because obviously that's not the shape that I've got drawn here. It is the knee that I've got, and sort of the back bulb. It's on the back of a leg. But I don't have, the sort of square front of the quadricep here that I would like. If this guy really dances all the time, he should have a better looking leg than this. So I'm going to make some edges here as far as what I want to have on the front and sides of this piece. So I'm going to draw two sketches on the front plane and on the side plane. Let's start on the side plane. And what I want to do is I just want to use the spline tool. And I'm going to do a couple of splines here that are going to be where the top of the leg is. And, whoops, before I do that, I've got these sketches shown. I'm sorry, the sketch planes shown. So when I go into my spline, what I'm going to do here is I'm going to make sure that I hit those two planes. And what's that's done for me is that's locked these endpoints to that top and bottom. So I know exactly where I'm going to start and end. Oops. I must apologize. I have skipped a page here. Let's go back to the fill because I forgot that I also wanted to turn this into a solid. I showed you this earlier and it didn't work for me. Hopefully this will work for me this time. If you've got an enclosed volume, it'll get you this create solid. Also, if you have even just a small gap, it'll automatically close those up for you so that it can turn it into an enclosed volume, turn it into a solid body. I just did that so that my the surfaces that I'm going to create here, I don't have to worry about whether or not I'm going to blend them together. The leg is the solid right now. Now I'm going to build a surface around it. So here we go. I'm going to draw that shape of the quadricep from the front. And what I'm going to do here, I don't know if you've used this tool before, but it's a favorite of mine, dynamic mirror. When you're using a dynamic mirror, anything you draw on one side gets drawn on the other side automatically. And so I want this shape right here. And remember, you can make these horizontal or vertical to make sure that you've got exactly where the end of this is going to be. So let me take a look at the drawing I have here and make sure that I'm giving myself, enough material here to fill in that shape that we're after. And these get really complex. You can play around with this stuff. Again, when you're using the style spline, it's really hard to get a bad spline. It's always going to be a nice smooth one, even if you move that stuff up and down, in and out. It doesn't really care. Okay. So there we go. And I actually want to create a plane here. If you hold your control key and you click and drag a plane, it automatically offsets a plane for you. And then you can just type in the value you want, hit enter, you got a new plane. Easy as that. I'm going to do the same thing here where I create a center line first, and then I want to pick sort of where the leg is crossing in my drawing. It's a dynamic, and then use my style spline. And notice you can get it to get relations put on there. They're always going to be the ballpark relations. It doesn't put them on there completely for you. To get a true horizontal or vertical, you have to pick that yourself. And apply them. Okay, again, I want to make sure that this sort of matches the picture that we've got. So these are both the edges that I want for the front of my quadricep that's going on this shape. Now I'm going to go into those other sketches that I was talking about. Here we go. I knew I had some problems when I didn't have the right things to connect to. So I want this one, and this one here. And again, these are 2-point splines, so I should have a tool that I can bring in here. And you'll see that you can play around with these pretty good as far as the control polygons, moving things around, trying to get it into that shape that you're after. When you have this tool, Instant 3D on, I really recommend that you have it on while you're doing this type of modeling. The thing it allows me to do is I can pick other sketch geometry and move it in real time. Or if I don't have that, I would have had to get out of the sketch. So it's just a nice tool for me to sort of massage things into the exact place that I'm after. If I want this thing to have that sort of going backwards, since it's attached to this spline, if I move that spline backwards, that sketch is going to go with it. All right, so you see it has a lot to do with just trying to get things in position. I'm going to do one more sketch here that's on the right plane. Again, a 2-point spline that if I'm facing the planes, I can fit in between the planes really easily. And then holding my control key down, I'm just going to make them so that they're even with these points on my shapes. Again, whatever shape I want this thing to take, how far back I want it to go, those kinds of things, I can manipulate that because I've got that instant 3D choice turned on. You know, if I want this thing to go a little bit backwards or whatever shape I'm after, we can do that. I'll have it come out a little bit. Okay, so I did that on the, that's what I want the, you know, as I'm looking at this thing from the side, that's what I want the front and back to look like. I'm going to do the same thing on the front plane when I'm looking at this thing from the front. Where are the left and right? Because you'll see that it's definitely not symmetric. So I'm going to need to do a couple of them. Again, I'll start off with 2-point splines that attach to the planes that I have set up as the top and bottom of this feature. Okay, for these ones, I want to make sure they line up with the back end of these. So they look a little weird right now because they're not actually in line with them, since they're on the plane that's ahead of them a little bit. They line up as I'm looking straight on, but they don't actually touch the curve that I'm after. And that's fine because that's not actually what I need these things to do. Oops. I do want to do them as separate sketches. I do want to have them a little bit of this shape that we want as far as this leg coming out. Again, if this is too far out, I can move the shape in and my sketch will change. So a lot of this stuff, and it gets a little bit more artsy-fartsy because I'm not typing in numbers here. You'll see that this is fully defined, but it's really not, because anyone can come in here and just start playing around with the magnitude of it. And that's just kind of something you have to deal with when you're in surfaces. They do allow you to put like angular dimensions and things like that onto spline controls, but it's really a lost cause. It's very difficult to get a fully controlled spline. Okay, one last time. Put this here and there. Line these up. There we go. And again, give whatever shape I kind of want to have on this thing. Okay, so I'm looking straight at it. I'll play around with the shape a little more. I'm not going to be doing the entire leg, so I don't have to worry about it too much. But there we go. Okay, I'm going to hide these because I'm done using them as place finders, and you'll see what I end up with, where I've got what I want it to look like from the sides, what I want it to look like from the back. So if I were to extrude this as a surface and extrude this as a surface, they're perpendicular to each other, so they would cross at some point, right? In fact, let me just show you what that looks like. Right, just as promised. They will cross each other at some place. And if I were to do something called an intersection curve, I can find out in 3D space where those two would cross each other, right? There's an easier way to do this whole thing. And that is using something called an intersection curve. It's on our feature tool, same place we find split lines and things like that. There's this project curve, and it does exactly what I just showed you. If I say I want this sketch and this sketch projected onto each other, that yellow line is where those two surfaces met. So it just shoots the sketches out perpendicular to each other, and wherever they cross in space, that's where you get it. You can also use this tool if you just have a single sketch and a face. You can pick the sketch, pick the face, and it'll show you where that line would be projected onto that face. I'll hit the Enter key again so that I get it to come up with the last command that I had. I want to do these two. So you see what that's done for me is it's actually given me where the back of this shape is. So I'm going to do another command here where I'm going to do a boundary surface. This one actually could be a loft or a boundary. Boundaries are always nicer just because they have more options. So you'll see that at each cross section, I can play around with tangency control, which you can't do on a loft. Also, when you've got a shape like this, I was talking a little earlier about when I had that circle and that ellipse. If I had guide curves on all four sides, it's a better idea to do the guide curves because you're not going to accidentally get that twist happening. If you use the ellipse or the circle as the guide curve instead of the actual cross section, usually you have better luck with that. But there you go, a nice smooth squared off front. I think I got it collapsing in on itself. Let me try that one more time. Yay! Okay, so I've got this shape. That's what I want for the front of the leg, but it's obviously not part of the front of the leg right now. So I'm going to create a solid geometry out of this as well and fit it to that other solid that I've got as the base of the leg. So I'll use the front plane on this thing. I'll just do a quick trim. Like I said, if you're doing standard, you can use a plane as your trim tool and pick what you want to keep or remove. So there's my first shape. I can also use a boundary surface sort of as a bridge. There we go. By default, it just goes the shortest of two. But if I set this thing to have curvature, point it the right direction, notice that, again, the boundary surface, each cross section has its own control. Again, I can put draft in if I really need to, but that's kind of the shape I'm after. I want it to go a little further, so I can just extend out that tangency all I need to. Okay, another nice thing about when you're working with surfaces or solids, you can quickly hide one or the other. And so I'm just looking at the surfaces that I'm after. I want these two to be knit together. And then I'm going to do a fill surface. Now I want to make sure that I get all the edges here. It's a good idea when you've got a knit surface is to right click and tell it to look for the open loop. And you'll see it actually found 3 edges, where if I had picked manually, I might have only gotten 2 and it would have failed. Also, when you're doing a fill and you set something like curvature or tangency, you can apply it to all edges with this checkbox. Another thing we can do when we're working with a lot of different things, I'm having trouble seeing my sketch now. I can make these things transparent or hide them using these columns as well. And the reason I'm doing that is because I want to see where the top crest of this hip comes in. Okay, so you see that when you do have these 2D splines, it's better to use a style spline. Because remember when I said it's really hard to get a bad spline with a style spline? It's really easy to get a bad spline with a regular spline. So just the controls on it can be tough. So again, if you are using a multiple point spline, it's a good idea to use the style spline. It is a little stranger to try and control it when you've got a curve, because you're not actually drawing where the spline is, you're drawing where this polygon is. What you should do is just get it around where you want it, and then you can start using these control polygons to pull it or push it into whatever shape you want. All right, come here. Here we go, and I'm just going to extrude this out as a surface. I showed you that you can trim these up, knit them together, all that kind of stuff that I was showing you earlier. But you can also use another command. Let me see. Called Intersect. And what Intersect allows you to do is you can pick multiple surfaces, and what it'll do is it'll find the enclosed volume in them for you. So it'll list all the volumes if there's more than one that it's found. Here it just found one. And if I go to the bottom here, if I choose to merge results, it's going to turn it into a solid and it's going to merge it into that other piece. Also, if I say consume surfaces, the surfaces will disappear. It only combined with things that are showing because I was hidden, didn't do it. But what it did do was it created a solid. So it trims them all together, it knits them up, it fills it with solid all in one shot using that Intersect. So it's a great tool for you, but that is how you can get a shape, like that crazy shape that I drew on a piece of graph paper and turn it into a real 3D solid model. Again, there's this example and there's another example as well, similar with that boogie bot. Do you guys have any questions on that, actually, before I close out of here? Also, before I close out of here, let me just combine these into a single body. And talk about filleting. I told you that when you do fillet an edge like this, it gives you something that's called a constant radius fillet or constant size fillet. You do actually have the ability to try and do curvature continuity. That's something new. I think they added that in 2018 or 2019, but it'll try and do a curvature continuity where before it would just give me that solid red bar without any kind of graduation, where here it actually takes a while before it hits the red bar. Let's see if I change it just to a regular one, if it backs up. Yep, so see how it's clean right at the edge? I'm going from flat, flat, and this is the curve. So they have been working on trying to get this curvature continuity better in SolidWorks. Unfortunately, one of our competitors, NX, has some really good surfacing controls where we can actually do that node control a lot better than SolidWorks can for getting areas if it fails. Because here it worked, but sometimes it'll fail and you don't really have any recourse when it does fail. Also, you can do another type of fillet called a face blend fillet, where you pick the faces that you want to have blend into one another, and that again has a curvature continuity. That's always had a curvature continuity. It's just the constant radius one had the choice added a little while ago. So you'll see that it tries its best. It did do some of that graduation in here, but it didn't do a great job up here, just because the corner's so tight anyways. So some of that you may have to do yourself, but they do give you a good job. This is really what you're trying to get, where it's a very gradual, then a curve, and then very gradual out of it. And again, that was done using that G3 trick in the sketch. Okay, how are we doing? You guys still out there? Any questions on this before I get into the last half hour? Yes,
I
sir.
had a question. That last G3 trick you were showing, it looked like in the sketch that curve wasn't fully constrained, yet it looks like everything stayed curvature continuous. And I was just wondering if you had a comment on that. I think the curves were still blue, if I remember, in that sketch.
Yeah, the curve was still blue. Like I said, it's really hard to get a spline. Even when a spline turns black, it still isn't really black because you can go into nodes and start screwing around with the tangency at it at different points. So when you're dealing with, prismatic features, cylinders and plates and things like that, we always want to have it black because we want to tell the guy, hey, this is exactly what we need. But when you get into this sort of organic shape thing, the fully defined is really tough to do. And a lot of times when you try to do it, you do more harm than good. You end up chasing your tail and things like that, where you're never really going to get it fully defined.
That's been my experience too, so I'm glad to hear that's what you.
Right. I wish I had a better answer. I wish there was a way to fully define it, because I certainly
Right.
would. I mean, you can put on a ton of controls. If we just look at a regular spline, I can put dimensions onto these things for the amount of magnitude that my tangency control has. I can also do it at an angle, you know? So I can put all these dimensions in, but I never really have it fully locked down. Um, so it's tough. You'll see that you can start to do it, but a lot of times when you do that, when you go to like do one of those tricks where you're, oh, this thing's a little lumpy, I want to massage it, you get a bunch of crazy stuff happening here because it's trying to stick to those dimensions that you put in. And that's where I talked about the more harm than good, trying to lock the thing down. Where at one point I sort of just was like, I'm going to be free and happy and not worry about this thing being fully defined. And after that, I was able to make surfaces a lot easier because it's one of those things. Like I said, when I'm dealing with a machined part or a turned part or something like that, I definitely want everything to be black so that I know I have all the dimensions somebody's going to need to make it or inspect it. But when we're dealing with something like this and it's a loosey-goosey surface and I want to be able to push and pull, and someone says, hey, can you make that corner tighter, or, strange relative terms like that, if I've got all those splines locked down, I've got a lot of dimensions to go through, and it's just a horror fest. Where if I have this instant 3D thing turned on, I suddenly start to get a lot more control over things because I can just pick and grab edges and things like that, like I was showing you earlier, in real time while I'm designing.
Cool. Thank you.
In fact, let me show you something about the different kinds of splines that I use, because I very rarely will use the regular spline tool anymore, except for when it's a 2-point spline. I always use it for 2-point splines. It's very easy. I can control the two ends of it, and it gives me a smooth curve in between them. But if I was going to build, let's say, a mouse, and so I'll draw what I would like the mouse to look like from the side. And I can squish this down a little, get a little bit of control over what's going on. I do want this to be horizontal, so we'll make sure it is. All right, so that's using the multiple point spline. I'm going to do the same trick here on the top plane. I'm going to do a style spline. And again, it seems a little strange just the way that you create it, because you're not actually drawing where the spline is, you're drawing this control polygon. But you do have control once you've got the thing done. You can put dimensions onto these as well. I showed you that you can put dimensions on nodes, but you can also put dimensions, again, if you have to worry about draft or something like that, you can put it right into your spline. But notice on this guy, when I get out of my dimension tool, out. Again, I can click and drag, and it stays, pretty well. It's not going to fold in on itself. This one, however, I can't say the same for. It also gets really bad when you start trying to get more control by putting in more points. It's sort of the same issue that I have when I try to put in more dimensions to control things. Notice that when I play around with a single node, it does not just affect the nodes next to me. It's affecting the geometry over here. It's affecting the geometry down here. It goes throughout the entire spline. So really hard to control and really easy to screw up things, like getting this little notch in here. Me taking that notch out is going to take me a while. Okay, here's another trick you may not have known before. If you pick a plane and you pick a sketch, there's a tool called Derived Sketch. It doesn't have a button, which is why you probably have never seen it. But what it did is it gave me the same sketch again in a different sketch. Doesn't really do me much good when it's facing this direction. But what I've done is I've made it so that this sketch, remember I've got my Instant 3D turned on to do this trick. I change one sketch, both sketches change. So this one is always the same shape and size as the original. I just have to give it a location. Okay, another thing I need to do is I don't want it pointing this direction. Here's a tool that I use a lot, Modify Sketch. If you've ever got lettering or whatever coming in backwards, if you type in Modify here or have Modify Sketch, Modify Sketch allows me to do different things. It allows me to move the entire sketch, so instead of clicking on an edge and dragging it and having my spline go all crazy, it's moving the whole thing as a unit, and I can move it a value X or Y if I want to. I can also scale it or rotate it. But wait, that's not all. See over here, this little black origin? If I right-click on the short leg, it flips it about the horizontal. Right-click on the long leg, it flips it about the vertical. Right-click that black origin, it flips it about both of them. So I can quickly get a mirrored version of that sketch that's always going to be the same. I mean, I could have done a mirror inside of the same sketch, but just a different idea. So another tool, I can see how this thing looks. That looks a little bit more like the mouse that I would like to create. Okay. I'm about to set myself up for a problem, and the problem is called a three-sided surface. It doesn't have to always be this shape. There's a lot of, even Revolve sometimes can be three-sided surfaces. What I'm going to do here is I'm going to create a surface out of here, whether a loft or a boundary, doesn't really matter. I'm going to do a loft because I only care about controlling there we go, the tangency at the beginning and end. There we go. Okay, so it even shows me zebra stripes. See how my zebra stripes are all jacked up here? It'll show it even worse when I go to evaluate. Okay, if you start seeing shapes like this, that's a problem, and that is often due to your sketch geometry. The underlying sketch geometry is not as smooth as it should be, and so just that little inconsistency on that spline comes out big when you look at the thing. So if I were to, if I hold my cursor over this, I can see that the radius of curvature goes from a 20 to a 40, then back down to a 40, and then over to a 30. So I've got a ripple going through here. That's bad. That one's easy enough to change. Like I said, the problem I had was too many spline points. You can actually just pick on a point and delete it. Hey, nice and smooth again. So be careful with those splines. Like I said, just a little monkeying with that, with those control lines or the control polygons can give you some crazy geometry very quickly. It gets amplified when you try and shoot it over a loft or sweep it down an edge or something like that. So be careful with that. Style spline is always the way to go. So that was the first problem, was just using the wrong spline. It was giving me a funny shape. But this is a three-sided surface, and it can give me problems down the line. It's not a guaranteed problem, but it could be. And I'll tell you why. A lot of times what people like to do with surface geometry is at some point they're going to thicken it or they're going to shell it, which is basically making an offset surface. So if I wanted this mouse cover to be a particular amount thick, I can do that. But the problem is that I have a convergence point, and that convergence point falls apart. Let me talk about it 1 second here again. Freeform. I talked about it earlier. I'm going to show you another example on it in a second here. But what Freeform allows you to do is you can pick a surface and then you can like add nodes to it and just start pulling on the surface. But if I pick a three-sided surface, two things happen. One thing is it tells me we're not going to be able to do any tricks with this because you have a three-sided surface. And the other thing it's going to do is it's going to show me what the problem is. See where these things are all converging at a single point? Same thing happens over here. That single point is the problem. That is the three-sided surface. Whenever you get a surface where it starts to run into itself and everything is coming to a single point, it can be a problem. And again, that problem happens usually when you thicken or you go to thicken or you go to shell and it doesn't. And it gives you some sort of error like, bad geometry. It doesn't really give you much of a clue as to what's happening, but this is what's happening. I can't thicken this thing to the outside because it's going to start to fall apart there. I can't do it to the inside either because it starts doing this. Because it says, okay, this point is offset there, and it's just terrible. So, okay, that's what a three-sided surface is and why it's going to could be a problem later. Ways to get around it. If this is just the shape I want and I want it shelled out, what you need to do is you need to overbuild. If I had built this thing like this, but the actual bottom of the part was going to be there, if I build more surface than I need, and I trim that out, now all of a sudden I do an offset surface, it's not falling apart in either direction because I've cut away that convergence point. So that means that this part will thicken, this part will shell. Without giving me an error where it would have errored out before I did that cut. The other way because I said it's a potential problem. Why does SolidWorks even let us get away with it if it's going to be a problem down the line is because it's only going to be a problem if that remains. So in the first fix I showed you, I said overbuild the thing and then just slice the convergence point away. The other thing is that what if this was along a pipe or a tube and it's just sort of a bulb that comes out where the convergence point really isn't part of the design anymore once this thing's completely built? So let's say this thing is just hanging around a pipe. Hey, come here. Okay, so those two. And I want to keep just these two. Keep. How did I not slice this thing? There we go. Okay. So if that's the shape that I actually was after, it's no longer a problem. Again, the solid body is going to thicken for me because the convergence point is gone. So be aware of what's going on when you do three-sided surfaces. A lot of times when you're doing like gas tanks or things like that, you'll run into this type of problem. You can either overbuild and slice away the convergence point, or if there's some sort of boss or something that's going to cover the convergence point, again, it's not a problem. You're going to be able to thicken and offset just fine. Any questions on three-sided surfaces? Okay, that has to do with some offset and items like that. One other reason people will use surfaces is doing things like overmold or inlay, coating, whatever you want to call it, like this piece right here. So I had a piece. I did a split line, show me what the part that I want to have rubberized. Then I offset. If you offset of 0, that's a copy. So you can either offset it with the amount that you want off and then thicken it the opposite direction, or here I did 0 and then thickened it to the outside. Or on the back here, I actually just extruded these pieces out here, offset a surface from the back, and then use that as a cutting tool to slice away how tall I want that inlay or that overmold. So surfacings are really good for, just saying, okay, I want to put a film around this, and then you can actually take that film and thicken it up if you want to do, like I said, an overmold or a coating. And then one last reason that people will do surface design is, I was telling you earlier sort of about a macro design where you've got not just one little part that you're building, but you're building a whole big system, and you can use the surface to help you make sure everything fits together. So I'm going to bring this thing up. And talk a little bit about how this was designed. So, of course, I wanted to have a flying personal watercraft, so I designed one. But the way that I created this was it all started with one model. So you see that all of my parts start off with this shape, where I've got this surface body that I'm going to use for the part. And from this, I can actually just right-click and start a new part right from here with just that surface as the first feature. When you do it in this way, you're going to end up with an external reference. So if I make changes to the master model, this is going to change. If you don't want that to happen, you can break the external references. See, it always wants to find this part. If it can't find it, it's just going to open up its last save with the question mark on that surface. If it can find it, it'll update any changes. If you don't want it to ever update or to have an external reference, you can just break that reference. But again, that's taken away the magic of the master model. It really depends sort of on where you are in the design process, whether you want to make that decision or not. You can always do it later as well. But when you've got an overmodel like that, where this is the whole thing, I can bring in this assembly and show you sort of how is really able to create this wing very quickly using the surface geometry that I just showed you. So if I roll back, there's our friend, the whole shape. And then I'm just working on the wing. So I sliced everything that I didn't need away and started using the geometry of the surfaces to help me build these spars and ribs, fully feature out. This. Just start sliding this around. There we go. So we got spars and ribs going through the middle of this and pipes holding it in place. So I use that surface as the main design. So I know that this skin's going to fit. When I snap it into the assembly, it'll automatically populate in place. What I mean by that, if this was an assembly here, usually when I'm doing an assembly, like you saw the last assembly I did, if I have the master model, I'll put it into the assembly itself. But a trick I like to do is if I go into the properties of this, I can turn it into an envelope. You'll see that it looks like a little snail mail envelope next to my part symbol. It also turns transparent. When you turn it into an envelope, what it does is it's not in the bill of materials, it's not accounted in the mass properties, it's just a phantom. It also helps me, if I have parts that reference this, is that they're always in date. It always loads up the master because I've got it in the assembly. But what I meant by it snapping right in place is this wing assembly, I just have to hit the green check mark and it comes in fixed in the correct position because I'm using the same model to orient where my items are in space. So yet another great reason for using surfaces. So that's my 2-hour class. There is another example of building the foot for our little robot. I'll send you guys both example files, the building the thigh as well as building the foot, to get your hands on the surfaces. Thanks everybody for coming. This will be, has been recorded, and I will be posting it if you missed any of it or would like to view it again. Other than that, thanks everybody for coming.
Thanks for